at doing proof by contradiction with irrational number questions. So assumption that we have the opposite. Irrational, not irrational, is rational. This can be written in this form here. Okay, similar to another proof you may have seen for this question. Before I go much further, I want to illustrate some ideas with square numbers. This will be important later on. And I want you to have a look at the 2's. So what do you notice for any square number? You notice it will have 2 squared, or 2 to the power of 0. That's when there is no 2 in it, because this all becomes 1. If it's a larger number, it might be 2 to the power of 4. Okay, I can write it in this form here. This is the definition of a square number, that it always has an odd power for any factors that it has. This will be really important later on. I'm going to manipulate this then a bit further. So these steps will be the same as other proofs you may have seen. So we square both sides, we rearrange, and we rearrange to 2b squared equals a squared. So this is where it gets interesting, because we're going to look at sort of the right hand side, the left hand side. We're going to come up with some statements, and we're going to find out what's happening here. So I'm going to start by saying a squared is a square number. Yeah, it's a square number. What do square numbers do? Well, you'll see this later. It has even powers. That's what a square number really does. Okay? If it doesn't have the number appearing, 0, we're still going to say that that's an even power. Okay? So, for the right hand side, a squared is a square number. A squared is equal to 2b squared. So the left hand side, yeah, is going to be the same number as the right hand side. So we can also say 2b squared is, it's equal. It's equal to a squared. So 2b squared must have even powers too, because they're the same number, aren't they? Okay, you can't be the same number if you have different powers. That doesn't make any sense. If you multiplied it, you wouldn't get the same number. There is a problem with this, however. So this all seems fine so far, but if we notice that inside 2b squared is b squared, this is a problem. B squared is also a square number. So b squared has even powers as well. Now the problem with this, if we do some examples, let's pretend b squared could have like 2 to the power of 4, for example. But what's going to happen? What's going to happen when you multiply this by 2? Because there's a 2 at the front, isn't there? When you multiply this, you're going to get an odd power. And that doesn't work, because then you have the number on the left has a different power to the number on the right. And that's not possible. It has to have the same power. So this is going to be our contradiction. So we're going to say, if we go back, let's change the pen again. So let's say b squared has even powers. So 2b squared has an odd power of 2. Yeah? So the powers of 2 on the left hand side do not match those on the right hand side. So this contradicts our statement. If we go back to the original, this contradicts our original assumption, that root 2 is rational, because it's just not possible to do this, and we've shown that that result is nonsense. So we accept that root 2 is going to be an irrational number. Okay, it's a little bit complicated to get your head around, but what I would encourage you to do is perhaps to have go with a couple of examples. And it doesn't matter what this power of 2 is here, this will be even and end up with an odd power that doesn't match.